No, I think this is 5. Okay. Anyone? Anyone, please?
38.
38. Very good. So for 38, we have, I'm going to replace it by f of x because it's easier to write. So x squared plus 9 over x squared minus 9. Perfect. So the same question. We want to determine critical numbers, and we want to investigate whether they turn into max or min, or none of the above. So what is the first thing I need to do in order to find critical numbers if they exist? What is the first thing?
Differentiate?
Yes, find the derivative, of course. So f prime of x, which rule applies here? Anyone, please? Which rule? Yes, the quotient rule. So I have x squared minus 9 squared in the denominator. When I square the top, what do I get? Can anyone square the top for us?
Square the top or differentiate?
Differentiate, I meant, of course.
Okay, I was.
No. I lost it for a second. I meant, of course, I meant differentiate. I have to differentiate the top. I get
2x.
Very good. Then I copy the denominator, multiply by the denominator, minus I copy the numerator, and I multiply by the denominator prime. Please do not distribute. Please. See, you have a common factor. Pull it out, please. Always do that. And then I have x squared minus 9. But now I have to be careful because I have to distribute this symbol to both inside. Because 2x from here and 2x from here are gone. So minus x squared and then minus 9. Everything over x squared minus 9 squared. So luckily, these two go away. I have negative 18 times 2, negative 36, x at the top, and x squared minus 9 in the denominator. You can leave the 36 at the top. I prefer putting the factors in front if it's possible. Good. So now I start my table with f prime first and f of x second. Now I have to be careful. We will always do this. I need a domain. I need to put the domain for x. Can anyone tell us what will the domain be for a rational function? Rational function. Can anyone give us a domain for this one?
X cannot equal 3.
Yes. It's quadratic. I have to have two solutions.
Or negative 3.
Yes. Which means there is nothing I can write under these. I'm not allowed to write anything. It's undefined. If the function is undefined, all derivatives will be undefined at that point. Guaranteed. Good. So now I need to investigate f prime of x being 0 and f prime of x being undefined where the function is defined. But this is undefined at positive or negative 3. But so is the function. So there are no critical numbers coming from f prime of x being undefined. Now, f prime of x equals 0, that's the reason why this is a number in front, it's a factor. You can write it or not, it won't make any difference. So x over x squared minus 9 squared equals 0. When is a fraction 0?
When the numerator is 0?
When the numerator is 0. So this is the only critical number. Will it be a max min? I have no clue. I haven't finished the work. So I know that the derivative is 0 at that point, but I need to find the sign change, if there is any. First, I also have to plug in 0 here. When I plug in 0, what is the function value at 0? The function value at 0, -1. So I already have the point in discussion. There is only one point in discussion, and that is 0, -1. Perfect. Now I need to study the sign left and right, which will be the sign the same here. So let's look at the derivative. Which piece of the derivative you will refuse to plug in numbers into? Which piece of all this? You will say it's a waste of time to plug in x values in such and such. Which one? Which piece of all this you will refuse to plug in, and why?
The 3 and -3?
I refuse to plug in numbers in x squared minus 9 squared. Why? Why I refuse to plug in numbers in here? What type of number will always be and forever x squared minus 9 squared? Try anything. What type of number will that be forever?
Oh, positive.
Correct. So why would I waste my time? I would not have to calculate or include 36. Who cares about 36? So the only piece that I'm studying the sign for is -x. So let's plug in a number to the left of 0 in -x and tell me the sign of the derivative. Any number to the left of 0, plug it in -x and tell me the sign.
Negative.
But it's -x and I'm plugging in negative numbers.
Awesome.
Awesome. So it's -x and I'm plugging in a positive number. What do I get?
Negative.
Yes. So now, what does the derivative do? What does the function do when the derivative is positive?
Increases.
Yes. Good. What does it do when it's negative?
Decreases.
Excellent. Now we know exactly what is 0, -1. What type of point is 0, -1? We do know. What is it? Relative?
Maximum.
That's it. It's a relative max, guaranteed. How do we feel about critical numbers so far?
Pretty simple.
Good. That's all I needed to hear. Any questions, anyone? Can we move on? Or we need to look at other? We will deal with critical numbers when we put everything together for graphing. That will be the starting point, after domain, of course. Any questions? Do we need more? Okay, I would like to go back and talk about absolute max, absolute min, which we already did. I'm on page 6. Absolute max or min on a closed interval. Of course on a closed interval. It's a closed interval. It doesn't go on forever. It's a closed interval. It starts somewhere, ends somewhere. Closed interval, starts somewhere, ends somewhere. That's when we discuss. We do have situation with absolute max or global max in other cases, but in this case, we're talking about closed interval. Okay. So let's choose. Find the absolute max and absolute min values of f on the given interval, 51 through 66. I scroll as slowly as possible, and you choose. And as you see, the closed interval is given to us. It's on the side of the function, right here. E to the x. And after that, I like to choose something with log, something with, you already have exponential. That's very good point, very good pick. Something with log and inverse tangent. So let's start with 60, perfect pick. So we have f of x equals e to the x 1 plus x squared. And the given interval is 0, 3. Awesome. Good pick, thank you. When the closed interval is given to us, our table will only have the closed interval in it and nothing else. Once this is given to us, this one dictates. So we have f prime of x, and then we have f of x, of course. Good. Like before, no change. I have to find the derivative. I have to look for critical numbers, and then I'll show you what happens next. Again, this is a rational function. It's a combination of exponential and rational, but still we have to use the quotient rule. The denominator is very nice. The numerator prime is e to the x times the denominator minus the top, which is e to the x, times the denominator prime. Can anyone give us the denominator prime? Anyone, please? Good. Please do not distribute. Please do not distribute. Please do not distribute. Factor out e to the x. 1 plus x squared minus 2x over 1 plus x squared squared. Now, can anyone factor x squared minus 2x plus 1 for us? X squared minus 2x plus 1.
X minus 1 squared.
Very good, awesome, great job. So indeed, x minus 1 squared. Two situations, f prime of x being 0 and f prime of x being undefined. Is this ever 0? Is 1 plus x squared ever 0?
No.
No.
Because you can't square and get a negative 1.
Exactly. It's positive plus 1. Yes. So there is nothing because 1 plus x squared is never 0, so f prime is never undefined. But can f prime be 0? Yes. F prime can be 0. E to the x can never be 0. So do not even bother with that. E to the x, remember the graph. Please remember the graph. This is the graph of e to the x. Always positive. Always. Now, what happens, what can f prime be 0 if this piece cannot be 0? Is there any other chance for f prime to be 0?
Yes, because can't the other part could be 0, and then when you multiply e to the power of x by 0, it
Good.
would become 0.
For what exactly? Well, which value of x?
1.
Exactly. So that's the only critical number. I put it in where it belongs. I put 0. And now I have to study the sign. So let's take a look. Which piece of this function you will refuse to plug in numbers in? We're trying to analyze so we're not wasting time. You can say, I can plug it in the graphing calculator and plug in numbers. Yeah, but we're discussing and analyzing this. Which piece of all this you'll say, I refuse to plug in numbers because I already know the sign?
The denominator.
Good. What else? Because it's always positive. What else? What else? You will refuse to plug in numbers in. Anyone? So these two situations are no different. They're not different, right? This is something squared. This is something squared. So I refuse to plug in numbers in these two. What about e to the x? Will you plug in numbers in e to the x? Nope. You will refuse to plug in numbers in e to the x because it's always positive. You will refuse to plug in numbers in x minus 1 because it's squared, will be always positive. You will refuse to plug in numbers into something squared again. So then what is the result? What am I saying to you about f prime? What am I saying
It's
to
always
you?
positive
It's always positive.
or increasing.
Always positive. Now I have to plug in the function because it's a closed interval. I have to plug in 0 and get this value. I have to plug in 1 and get this value. I have to plug in 3 and get this value. So I'll share my screen. So in y equals